UDP is the free spirit of network protocols. It's intentionally connectionless and unreliable. It just flings datagrams out into the world without any formal introduction, acknowledgement, or follow-up. Now that might seem a bit careless, but for some applications, it's spot on. Consider DNS, DHCP, VoIP, video streaming, TFTP, and SNMP. These apps love UDP because it fits them like a glove. Grasping which applications run on UDP and the reasons behind it is a must-know for the CCNA exam. DNS hops onto UDP port 53 for its queries. Picture it as a quick Q&A session. You ask, it answers, and nobody sticks around for chit-chat. Meanwhile, DHCP takes over UDP ports 67 and 68, playing the dynamic server-client duo. It's all about shouting across the network to snag an IP address, and since you start without one, TCP's not in the cards here. TFTP hangs out on UDP 69, handling simple file transfers with a straightforward acknowledgement system. Then there's SNMP on UDP 161 for polling and 162 for traps. It's like the ever-watchful hall monitor of your network. RIP cozies up with UDP 520, spending its days counting hops. NTP is busy over on UDP 13, making sure everyone's clocks strike the same hour. And VoIP, it cruises along with RTP using UDP, dipping into those ephemeral ports between 16,384 and 32,767 to ensure your calls are smooth and clear. Think of it as the live DJ, expertly mixing tracks for your conversations on the go. Applications have their own clever reasons for picking UDP. Look at DNS. It favors UDP because it just needs a quick, single-packet exchange without the whole three-way handshake ordeal of TCP. Now consider DHCP. It relies on UDP because initially the client doesn't even have an IP address. It needs to broadcast out, and TCP can't do that without already having an IP setup. Then there's VoIP and video streaming. They choose UDP because if a voice packet shows up 200 milliseconds late, it's about as useful as trying to catch yesterday's bus. The conversation's already moved on. And TFTP? It uses UDP too, but it throws in its own simple stop-and-wait acknowledgement system. Let's dive into some common pitfalls with UDP. First up is DNS. This one's a bit of a shapeshifter, using both UDP and TCP. UDP is the go-to for queries under 512 bytes, while TCP takes the stage for zone transfers and larger responses. Think of DNS like a restaurant that switches from a fast food window to full table service depending on how big your order is. Next, there's TFTP. It sticks to UDP but has its own way of saying, "Got it." So, while it might seem unreliable, it's more like a diner with no reservations but a waiter who never forgets your face or your usual order. Radius is third in line, using UDP exclusively. But then came Diameter, which decided to spice things up by supporting TCP too. Imagine Radius as someone happy with a bicycle, while Diameter upgrades to a car for a fancier ride. And lastly, HTTP3 is shaking things up by using Quick over UDP port 443. That's right, even web traffic is embracing UDP these days. It's like your favorite hotel now offering a glamping experience. Modern comfort with a nod to tradition. So that's the world of UDP applications like DNS, DHCP, TFTP, and VoIP, and why they choose UDP instead of TCP. Keep at it, and you'll get the hang of it. Swing by Courseiva.com if you're hungry for more.